review of the class. Woohoo! All right, we're going to look at some more examples of our quadratic equations where now they want us to find the vertex. They want us to find the equation of the line of symmetry. So this is going to be the equation of a vertical line. They want us to find the maximum or minimum point. That's the highest or lowest y-coordinate on your graph. Hint, hint, that's going to be your vertex location. And all x and y intercepts of the graph. Well, because the equations are always going to be given in general form, the rule of thumb is to find the y-intercept first. A y-intercept is located at 0, c. Now, because these are ax squared minus bx minus c, that's your y-intercept, the constant at the end. If you put that 0 into this x, that's a 0. You negative 10 times 0 is 0. These terms zero out, and 0 minus 3 is still just minus 3. So there's the y-intercept. That's done. Scratch that off the list. Then the vertex will be next, line of symmetry and max or min, and then finally your x-intercepts. So now because this has a 1 in front of your x squared, the quickest and easiest way would be to find the vertex by completing the square. All right, so we're going to turn this into this. Now, my vertex form of this is going to be y equals x minus 5 quantity squared minus 28. Well, how did you do that so fast? Well, if you do this completing the square so many times, remember we're taking half of a minus 10. That's minus 5. Go put it in the parentheses squared. And then remind yourself, oh, okay, then 25 is going to be 5 squared, and you subtract it from the minus 3. Remember, plus blank on the inside, minus blank on the outside. So you can start to probably get this done between your ears after you practiced it enough. So there's my vertex. Remember, we say what's in the parentheses, solve it for x. That's a positive 5, negative 28. There's your vertex. Now, your line of symmetry, max or min, are all going to be here in the vertex. The x-coordinate 5 is going to be your line of symmetry equation at x equals 5. You have to write down x equals. If you just put a 5, it will be marked wrong. This is the equation of a line. All right, now your max or min, well, that's going to be decided based on which way this parabola opens. And because your a is a 1 and it's positive, it opens up, which means my vertex is at the bottom, and therefore your y-coordinate now, the negative 28, is your minimum value for this graph. So x equals 5, line of symmetry. Your y-coordinate, negative 28, becomes your minimum value for the graph. So if you think about drawing a real quick picture, 5 to the right, down negative 28, I'm down here in quadrant 4, and it opens up. At some point in time, my graph has to cross the x-axis. So now to find the x-intercepts, we go back to this equation right here. Y equals the binomial x minus 5 squared minus 28, and you set it equal to 0. And so we're going to add the 28 over. We're going to take the square root of both sides, plus or minus. Wait a minute, 28, I know there's a perfect square of 4 in there. 4 times 7. So the square root of 4 is 2. We can put that in front here after the plus or minus, and 7 on the inside. And then we'll add the 5 over and put that in front of our plus or minus. So now my two x-intercepts are 5 plus 2 square root of 7 comma 0, comma 5 minus 2 square root of 7 comma 0. Notice my vertex my y-intercept, and my x-intercept. These are all written as points. Now, if when you type in your text box, they give you the plus or minus icon to click, you can type it and put your plus or minus right here and only have to write the point once. So that depends. If they give you the plus or minus icon, go ahead and use it. If not, we have to write it twice. All right, next example, y equals 4x squared plus 8x plus 5. Oh, first things first, let's do your y-intercept, 0, 5. Now, because we have a 4 here, I think I'm just going to go to the vertex formula. So I'm going to find my negative b over 2a, negative 8 over 2 times 4, negative 8 over 2 times 4. That's going to give me a negative 1. And now I need to find f of negative 1. So this one, because my x is negative 1, this one won't be too bad. So I will have negative 1 comma 4 times negative 1 squared plus 8 times negative 1 plus 5. And I think we can do this one between our ears because negative 1 squared is 1 times 4 is 4. 8 times negative 1 is a minus 8. So 4 minus 8 is minus or negative 4 plus 5 is going to be a 1. So there's my vertex at negative 1, 1. So as soon as you have the vertex, then you can do the line of symmetry. X equals negative 1. It's an equation. Because 4 is positive, my parabola opens up, and therefore we have a min at the y-coordinate of 1. So again, if you think about drawing a picture like we did here to determine if I have x-intercepts, all right, negative 1, 1 to the left 1, up 1, that puts my vertex in quadrant 2, opening up, and will never have the chance to cross the x-axis. So by building this picture here, that justifies that there's no x-intercepts. And you're done. If you don't make a graph and you take and write the equation and solve it, you're going to get an I in your answer. No imaginary numbers can be in a point. All right, next example. Looking for the same information, y is equal to x squared minus 7x plus 4. Y-intercept, 0, 4. All right, vertex, I'm going to go complete the square here, but I might need my calculator here. I'm thinking x minus 7 halves in my parentheses squared. And then I need to subtract 49 over 4 because I got a square that's 7 halves. So let's see, 40, oh my gosh, 4 minus 4. You know what? I'm going to go to my calculator. I can just type in 4 minus 49 divided by 4. Hit the math button, ask it to return your answer as a fraction. Negative 33 over 4. Okay, there's the k value. Just to speed things up for us. So there's the location of my vertex. Now, line of symmetry, x equals 7 halves. All right, now here we have a positive x squared, so we're opening up. So again, we are at a min value of negative 33 over 4. So next we're looking for our x-intercept. So if I picture my graph from my vertex here, positive, negative, that puts me down here in quadrant 4 somewhere with my vertex. With my parabola opening up, I have 2 x-intercepts to find. So let's take this equation here, set it equal to 0, and we'll solve it. Add over the 33 over 4. Next, we'll take the square root of both sides. So plus or minus the square root of 33, I cannot simplify, but the square root of 4 I can. It's a 2. Add the 7 halves over. We sneak it in front of the plus or minus. And there's my x-intercepts. All right, first point, 7 halves plus square root of 33 over 2, comma 0. Second x-intercept is with the minus sign. Now again, like I said earlier, if you click on the text box You put in the 7/2, they give you the fraction icon, and if they give you the plus or minus icon, go ahead and click it, put in your second fraction, comma 0, and that's the only point you have to put in. It's counting them as both of them. All right, next example, again, finding the same information. Y equals, this case, a negative 2x squared plus 5x plus 3. So again, y-intercept is the quickest and easiest to find first, 0, 3. Vertex is going to be by the vertex formula. So we're going to go negative 5 over 2 times negative 2. So negative and a negative will be a positive, so I'm going to have 5/4. And then we're going to put 5, wait a minute, we're going to put 5/4 in here. All right, again, you can go to your calculator, you can graph it like we tested, or you can go ahead and type in negative 2 parentheses 5/4, close the parentheses squared, plus 5 parentheses 5 divided by 4 parentheses, close it up, plus 3, and say, return my answer as a fraction. So in my calculator window here, there's where it says return my answer with after the plus 3. Return it as a fraction, I get 49/8. So plus 3, and that return fraction command is a little off the screen. So there's my y-coordinate of my vertex. Once we have the vertex, line of symmetry, x equals the x-coordinate, 5/4. Now here my a is negative 2, so the parabola is opening down. So now my vertex is at the top of the graph. Now we have a max at this y-coordinate of 49/8. So x-intercepts are next. So again, think about this point, positive, positive. I'm in quadrant 1 somewhere, opening down. My graph must cross the x-axis. So what I need to do is solve that equation for x. Okay, so what I'm going to do is I'm going to take my negative 2, put that in front, parentheses x minus the 5/4, close the parentheses squared, plus 49/8. So there's my vertex form. Remember, this a of negative 2 is the same as the a in this form. You found the h, you found the k, plug it in. Now set it equal to 0 and undo everything from the outside to the inside. So we're going to subtract over negative 49/8. And then we're going to get rid of the negative 2. So in this case, instead of dividing by negative 2, which I could do, I don't want to put a divide by negative 2 over here. So what I'm going to do, because of this fraction here, is I'm going to multiply by the reciprocal of negative 2, which is negative 1/2. That way the negatives cancel to a positive, the 2's cancel out to a 1, and it's canceled. Over here, negative times a negative is a positive, and now the 2 just gets multiplied to that 8, making it 16. Well, wait, these are really good numbers because they're perfect squares. I'll take the square root. I'm going to get 7/4 with my plus or minus. Now, because remember in the past, if this square root symbol completely simplified away, we have 2 equations to find. We'll add over the 5/4, 5/4 plus 7/4, and 5/4 minus 7/4. So 5 plus 7 is 12. Divide by 4, 3. 5 minus 7 is negative 2 over my 4, which reduces to negative 1/2. So my x-intercepts are 3, 0, and negative 1/2 is 0. And that wraps up all the information about a quadratic equation's graph.